All right, welcome to this weird lesson on Leslie matrices. And there's going to be a part of this lesson, probably from the get-go, you're going to be thinking to yourself, are we in math class anymore? What on earth is happening? But just stay with me. Hopefully it will make sense. The first page might get a little wordy as we read through just definitions, but make sure to hold on until we get to the example and everything will make crystal clear sense once we're there. But let's begin by reading through some definitions. The Leslie matrix. The Leslie matrix is a special type of transition matrix used to model the growth of a population, usually from year to year. Unlike a regular transition matrix, the columns of a Leslie matrix do not add to 1. So that's our very first important thing to take note of. A Leslie matrix is a type of transition matrix, but unlike our usual transition matrix, the columns do not add to 1. So that's something really important to take note of. The Leslie matrices only take into account the females in a population, as they are the ones giving birth to the new members of the population. So another thing that's really important to remember is that the Leslie matrix only cares about females. Every time we talk about the Leslie matrix and we talk about birth rates and survival rates, we are only considering the females. Okay? Let's keep reading. The Leslie matrices take into account the distribution of ages over time. The population is divided into equal-sized age groups that encompass the lifespan of the species. A Leslie matrix is a square matrix presented in the following form. Let's now look at it. And before we start jumping into this, the very first thing we need to remember is that this can only ever be applied to animals, not humans. And as we go through this, it will make sense as to why this is the case. All right. You need to get two highlighters out. Two highlighters, please. And the first thing you're going to highlight in one color is this. That first row is giving you the fertility rate. The fertility rate. Another word for fertility rate is birth rate. Birth rate. Remember, the Leslie matrix is telling us about population growth. And a major thing that impacts population growth is how many babies everyone is having. So that's the first thing we're going to consider. How many babies is everyone having? So as you can see up the top, we've got the ages of the people in the population, and this is giving us the birth rate or the fertility rate, the amount of babies people are having. So as you can see, if we're looking at 0-year-olds, f of 0 is going to tell me, well, what's the average amount of babies being born to 0-year-olds? Now remember, this is only ever going to apply to animals because humans can't have babies when they're 0-year-olds. But if you're a bird, you can probably have a baby when you're a 0-year-old. Maybe, I don't know. But in this world, that's what we're saying. F of 1 is going to tell me the average amount of babies born to a 1-year-old. F of 2 is going to tell me the average amount of babies born to a 2-year-old. Now, another important thing to remember is that a Leslie matrix only cares about females. So when we read the definition of what f of 0 is giving to us, f of 0 is the average number of females born to each female that is less than 1-year-old. So we only care about the female babies here. So this is the amount of females born to each female. Okay? F of 1 is the average number of females born to each 1-year-old female. F of 2 is the average number of females born to each 2-year-old female, and so on. Okay, the next thing I want you to highlight is this diagonal. Now, the other thing that impacts population growth, because remember, that's what a Leslie matrix cares about. It cares about population growth. The other thing that impacts population growth, apart from birth rate, is your survival rate. Your survival rate. And that's what these diagonal numbers are telling us. So P of 0 is telling me the survival rate, so the average survival rate of a 0-year-old to a 1-year-old. P of 1 is telling me the average survival rate of a 1-year-old to a 2-year-old. And remember, we only care about females here. P of 0 is the average survival rate of females that are less than 1-year-old. P of 1 is the average survival rate of females that are 1-year-old. Did I say less than before? I think so. Now, once you are 2 years old or older in this Leslie matrix here, guess what? You are dead. You're not making it past 2 years or older. There is no P2 value, indicating that no females aged 2 years or older survive into the next year. There's a hard cutoff for this particular Leslie matrix. Of course, all Leslie matrix might look a bit different. You know, this could go up to 5 years or 7 years or 10 years or whatever. But there's always going to be some sort of hard cutoff where we're saying, all right, everyone's dead at this stage right here. Okay, just to recap for a second. A Leslie matrix is about population growth. The two things that impact population growth are your fertility rates, how many babies are being born, and your survival rate. How long is everyone living for? So that's why we have these two components of our Leslie matrix. Now, there is also something called a life cycle transition diagram. Ta-da. The life cycle transition diagram is just another way of representing the information we have in a Leslie matrix. Okay, so this P of 0 and P of 1, this diagonal here, is represented by these numbers. So this is telling me the average survival rate of a 0-year-old to a 1-year-old, the average survival rate of a 1-year-old to a 2-year-old. And then we have people going back, and this is the fertility. So these are the fertility ones. Let me grab my highlighter. Fertility. So this is telling me, if I was to look at F of 1 for a second, what is the average amount of female babies born to female 1-year-olds? And as you can see, it's going back to 0 because when you give birth to a baby, it's 0-year-old. And then F of 2 here is telling me what is the average amount of babies born to female 2-year-olds. So the average amount of female babies born to female 2-year-olds. That's what's happening here. So this transition diagram is just another way of representing what we have in our Leslie matrix. So again, highlighting here is probably good because those numbers correspond to those. All right, hopefully I didn't lose you there. If I did, don't stress, because as we now head into the next part of this video, this will clear things up as we go through an example. I'll see you there.